All right, so now let's look at another piece of inverses. So before we, never mind, we're going to get to that. Okay, let's just look at this really in detail, the slow way, the, okay, that makes sense, okay, way. And then I'm going to show you the quick way. Okay, so if we start with this, we always start inside the parentheses. And so we're trying to find arcsine of 0.5. Now, arcsine of 0.5, I'm saying, okay, if I look at the unit circle, arcsine, sine is the y value, it's 1/2, that's 30 degrees. Okay, so this right here is 30 degrees. So I'm saying sine of 30 degrees. Well, let me see, sine of 30 degrees, okay, I'm right here, sine of 30 degrees is the y value, that's 1/2, which is 0.5. And you should be saying, wait, now, I feel like I just redid what I already did, right? Because we found the arcsine of 0.5, we found that's 30 degrees, and then I took the sine of 30 degrees, and I got 0.5. I got the same answer. And then, like you should. This is actually sine and arcsine are the inverses. You know, you can relate this to if I had the square root of x and then I squared it, how the square root and the squared cancel and it's just what's inside. Well, that's happening here. Sine and arcsine are canceling, it's just what's inside. It's that easy. Except, of course, there's twists later on. But let's just look at another one. Cosine and arc cosine, they're the same thing. They're going to undo each other. It's just what's inside 1/3. It's amazing. Look at that. It's just so easy. Of course, there's just, okay. Tangent of tangent inverse, going to cancel out, and we get just what's inside 3. So the question is, where does this twist come in, right? The twist comes in when we switch around. If you notice these last ones, they all had sine on the outside and arcsine on the inside. See, the first thing we did was already restricted. It was already within that restriction, you know, the first and fourth quadrant for sine. It was already there. So then when we did our outside math, we didn't have to worry about restrictions because it was already taken care of in the first place. Now, if we look at here, the problem is there's no restriction here. We can get whatever we want. And then out here, we have to deal with the restriction. So these can sometimes be as easy as just canceling them out, and sometimes it's some math that we have to do. So if you remember the last ones, the number here was the fraction or the decimal. And if that's what's happening, if that's a fraction or decimal there, then you're good to go. You can just say the answer is whatever that fraction or decimal is. But if the problem is an angle, if it has an angle in it, now all of a sudden we have to say, wait, now angles are restricted. Numbers themselves, these decimals are not restricted, but the angles are. So the first thing you're going to do is you're going to say, okay, I'm working with sine. So if I look, sine is in the first and the fourth quadrant. This one says pi over 3. Pi over 3 is in the first quadrant. It's within my restriction. So, because it's in my restriction, I can go ahead and cancel out sine and arcsine, and my answer is just what I have inside. So where does that come into play differently? Well, here I have arcsine and sine. I want to cancel them out, but first I have to check because this is an angle. 5 pi over 3 is over here in the second quadrant. Now all of a sudden we have a problem because it's not in the restriction. So it's not going to be 5 pi over 3. Now, here's what you do when it's not going to be 5 pi over 3. The sine value at 5 pi over 3 is root 3 over 2, right? It's a y value. So now you go to the restriction area. You go over here to first and second, or first and fourth quadrants. We know we want a y value that's positive, so that means the first quadrant. We figure out what angle gives us pi, or root 3 over 2, and that's over here at pi over 3. So my answer is going to be a pi over 3. So basically I'm looking for what other angle will give me the same answer, but's in my restriction. Let's look at some more. Okay, so here's arc, cosine, and cosine. I want to cancel them out, but first I have to look at where are they in the restriction. Okay, now cosine is in the first and second quadrants. 5 pi over 6 is right here at the second quadrant. It's within my restriction, so it's safe to cancel out and just say 5 pi over 6. All right, the next one, it's cosine and cosine. So once again, I'm still in the first and second quadrant. 11 pi over 6 is over here in the fourth quadrant, so that's a problem. So 11 pi over 6, I can't use 11 pi over 6. I have to use something else that gives me the same thing. Now cosine of 11 pi over 6 is a positive root 3 over 2. Now if I look in the first and second quadrant where my restrictions are, Positive 3 over 2 is going to happen in the first quadrant. It's going to happen with the same reference angle. This reference angle is 30 degrees, so this one's 30 degrees. Be careful though, this was given to us in radians. So this is going to be pi over 6. So my answer is pi over 6 because it's in my restriction and it still gives me the same answer as what 11 pi over 6 gave me. So that's my answer, pi over 6. So we're going to look at a couple more examples here. Okay. Now, again, remember when I told you, if the number in here is just a fraction, it's not an angle. If it's just a fraction, then we can go ahead, sine and sine cancel. This is just 2/3. Okay? But if they give us an angle, we have to worry about the restriction. So cosine's in the first and second quadrant. Pi over 3 is in the first quadrant. We're good to go. Cosines cancel, we get pi over 3. Okay, let's look at the tangent here. Tangent inverse inside, it's a decimal. That is not an angle. We can go ahead and just say 0.7. Done. Arc sine of an angle. Darn it, we've got an angle. So we have to draw our unit circle. Remember sine is in the first and fourth quadrant. This is 4 pi over 3. That's in the third quadrant. So we can't use 4 pi over 3. 4 pi over 3, sorry, it's down here. 4 pi over 3, the sine value there is what, 3 over 2. Positive. No, negative. Negative. So, since it's negative, we have to be in the fourth quadrant. And so this is going to be at negative pi over 3. It is not going to be at 5 pi over 3 because remember we have to use our negative values in there. So it's like we're going from the axis down, so we're getting a negative angle. Okay? So you're doing negative pi over 3. Now, let's just look at one more example. Let's say it said arc sine of 5 pi over 3. Now remember, our restriction's in the first and fourth quadrant. 5 pi over 3 is in the fourth quadrant. The problem with that is when we're in the fourth quadrant, we have to use the negative version of the angle. 5 pi over 3 is not the negative version of the angle. It's the positive version of the angle. So the negative version of that exact same angle is negative pi over 3. And so that's what your answer has to be. It cannot be 5 pi over 3, even though it's in the right quadrant. All right, practice these, think through them, watch the video over and over again, and ask questions if you have them. Good luck.